Hey guys, it's Mrs. McDaniel. I am really sorry this video is late. I did not get it up on Friday. Sorry, it's Sunday night. Really wanted to get this up for those of you who are absent. So I do apologize, but here it is. It's over 5.1 radicals and imaginary numbers. The success criteria is at the top. Simplifying radicals with negative radicans, which means there is a negative under the square root. And we're going to solve quadratic equations with imaginary solutions. So let's hop right in. At the top, it says, let's try solving this quadratic. Hint, isolate the x. So there's not a lot of room. I probably should have spaced this out a little bit better. But when you go to solve this equation and you subtract 20, and we're solving it using the square root method, which was on the last test, you get 2x squared equals negative 20. And then you divide by 2. So you get x squared equals negative 10. And then you square root. And we get x equals, but then we go to square root negative 10 in our calculator, and we can't do that. So part of the problem with square rooting a negative is we get a syntax error, or if you really dive deep, there's no real number out there that when you multiply it by itself will give you a negative, because a negative times a negative gives you a positive, and a positive times a positive gives you a positive. So there's nothing out there that would be the same number that would give you a negative. So it is where we go into the imaginary unit I. And the reason why this happens, you guys, because there's a little screen down here that shows you right here in this corner that this is just an instance where if we graph that quadratic, that there wouldn't be any solutions, meaning there's no roots that hit the x-axis. It is above the x-axis, so it never crosses it. So you'll see just below there, it says, notice how this graph has no x-intercepts and therefore does not have any roots, x-intercepts, zeros. There are no real solutions to this equation. Equations like this led mathematicians to define the imaginary numbers. So the imaginary unit I is defined to be negative 1. The square root of negative 1, and numbers of the form 6i, 2i, I root 3 are called pure imaginary numbers. These numbers are square roots of negative real numbers. So we're going to talk about how to square root a negative real number and how to kind of break it down. Because if you do put any of these into your calculator, it will give you an error. So what we do is we break these first ones down. This first row, you'll notice these are all perfect square numbers. Before we get started, I'm going to go ahead and write the perfect square numbers over here, mainly because you are going to need them. Frequently, if you're not very good at them, you might want to write them at the top of your paper. 1 times 1 is 1. 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, and 10 times 10 is 100. So those are perfect squares, and you'll see that 25, 81, and 49, they're all perfect squares. But they're negative. So they're not going to just be 5 or 9 or 7. So what we're going to do is we're going to break this down to negative 1 times the square root of 25. And what happens here is we then can find the square root of 25, which is 5. And then we can find the square root of negative 1, which is I. Because we have this right up here. I is defined as the square root of negative 1. So we're basically breaking those down, those perfect squares, down to a perfect square, which is 81 here. And we're pulling out that square root negative 1. Basically, that's square root 81 times square root negative 1. And the square root of 81 becomes 9, and the square root of negative 1 becomes I. So you get 9i. And then the last one, square root negative 49, it breaks down to square root 49, square root negative 1, which is 7i. So these are your answers for the first 3. Now the next 3 are not perfect squares, but they do have a perfect square that can divide into them. So if you look at the number 27, it is divisible by one of these numbers on the left. So again, we're going to use all of these again. And when I look at them, I'm like, does 1 divide into it? Yes. 1 doesn't really help, though. It doesn't break it down any. Does 4 divide into 27? No. Does 9 divide into 27? Yes. Is there anything higher that divides into 27? 16 doesn't. 25 doesn't. And then once I go higher than 27, it's not going to break down. It's not going to divide into it. So this is going to break down to square root 9, square root 3, because 9 times 3 is 27, square root negative 1. Now 9 becomes 3, square root negative 1 becomes I, and then you just leave the square root of 3 under the square root. So you always want to pull out a square root of negative 1 so that you can change that value to an I. And then if there's a perfect square root that divides into it, you break it apart like we kind of practiced in the last chapter. So let's look at square root of negative 18. It also is divisible by 9. So I'm going to break this down to root 9, root 2, root negative 1. Root 9 becomes 3. Root negative 1 becomes I. And the square root of 2 just drops on down to be the square root of 2. You can't break that down any further. It stays under the square root. The 9 does not stay under the square root because 3 times 3 is 9 and we are square rooting it. So it does not stay under the square root. That is why it is left out. There were a few people in my other classes when I was walking around helping them that they took the 2 out from under the square root and then left the 9. But that's not right. The 2 is still under the square root because we cannot square root 2. We can square root 9, and it is 3. So that is why we do that. All right, let's look at the next one. 54 is also divisible by 9. They're often, it's 9 is a perfect square root that goes into a lot of them. We don't go usually any higher than 100. Sometimes 16 or 36 might divide into it, or 25. This breaks down to root 9, root 6, root negative 1, because 9 times 6 is 54. Root 9 becomes 3, and then root 6 will stay, but I'm going to go ahead and put my I in between. Some people did ask if the order matters. We do like to have the I out in front and kind of like to have the 3 out in front too, because it's hard to tell what's under the square root if you put it in the back. So we usually put those 2 out in front and leave that square root sign second. But technically it doesn't really matter. It just looks better that way. All right, on 7 and 8, we are going to go ahead and multiply these together first and make this root negative 24, and then see what we can break this down into. I know 4 divides into that, and I think that is all, because 4 is a perfect square. So I'm going to break this down to root 4, root 6, root negative 1. So I get 2I, because that root negative 1 becomes I, root 6. Root 6 doesn't need to be broken down to root 3 and root 2 because those aren't perfect squares. The only reason why we break them down is if they're a perfect square, if there's a perfect square factor that divides into them. Okay, this one's going to become root negative 60 when we multiply it. Now, 60 is divisible by 4, and it would be 60 divided by 4 is 15, and I don't think there's anything bigger than that goes into 60 that's over in this list. So I'm going to do root 4, root 15, root negative 1, and this will become 2I root 15. And then the last one is just negative 5 times 3I, which is just negative 15I. That's it. Now, you guys do have some problems like this down here. And I did at the top of mine put that list of perfect squares at the top. Look for some larger ones to divide into some of these, so it won't always just be 4 or 9. I think 36 actually divides into one of them. So make sure you're using the largest square root that you can. Like, for instance, on number 2, if you do 32 is divisible by 4, but it's also divisible by 16. So this one would be better to break down to root 16, root 2, root negative 1, and then do your breaking down of those. So be careful. Use the largest square root. Okay, let's go back up here. Since I equals square root of negative 1, what does I squared equal? Well, if you square this, if you square root, you are getting rid of that square root. So this will equal negative 1. So I squared actually equals negative 1. So we'll talk a little bit more about that as we go on. Okay, the last one says solve each quadratic using the square root property. Graph each quadratic to verify why the answer is imaginary. You can use your graphing calculator to graph these, but all of these should graph above the axis, so you should be able to see that if you were to graph it. So we are going to subtract 16 when we start this problem, and we get x squared equals negative 16. And then when we go to square root, we're square rooting a negative, which is a problem. So we're going to break that down to root 16, root negative 1, and we get x equals 4i. And it will be plus or minus 4i because we will have two imaginary solutions. Because remember, that was really our only option. It was one real solution under the discriminant, two imaginary, or two real. So let's take a look at 11. We're going to subtract 80 just to begin. This is solving using the square root method. 2x squared equals negative 80. And we'll divide by 2. And we get x squared equals negative 40. And then we're going to square root. Well, negative 40 for sure breaks down those perfect square numbers again. I know 4 goes into it, and I actually think that's the highest. Root 4, root 10, root negative 1. Oops, let's erase that x squared. We already square rooted it. So root 4 becomes 2, root negative 1 becomes I, root 10 just stays, and it's going to be plus or minus 2i root 10. Okay, finally on these last two, we'll subtract 21, and we get 7x squared equals negative 21. And I'm actually glad we're doing this one because what happens on this one when we divide by 7 is we get x squared equals negative 3, and when we square root both sides, negative 3 doesn't really break down. There's no perfect squares that go into it, but you can still break it apart to a negative 1 and a positive 3 under the square root. And this will become I, and this square root 3 will still be square root 3. So the I just hangs out in front. It's I square root 3, which is totally legal. Okay, last one here. If I divide by 2 first, I get n squared equals negative 72. And then when I square root, got that negative under there. I know that a lot of people will think 9 first and foremost, but when you do 9, 9 goes into 72 8 times, and then 8 is then again divisible by 4, a perfect square root of 4. So I know there's actually a larger number that goes into 72. 36 is half of 72. So I'm going to do root 36, root 2, root negative 1. And root 36 is 6, root negative 1 is I, and then you just bring your root 2 down. Oh, and I did forget my plus or minus over here and my plus or minus here. There are two imaginary solutions. So, okay, that wraps that up. Hopefully that helps you. I will get this online for you to watch. And if you need to come in and see me, come grab a pass for AI or seminar.